In Activity 7, Airfoils, students learn how the airfoil shape of the wings helps an airplane achieve lift. They first identify the curved shape of airplane wings and then construct model wings to observe the effect of moving air on each model. Students finally relate their observations to Bernoulli's principle. You will need the following materials from the kit: Activity Sheet 7, plastic straws, a roll of string, 2 rolls of transparent tape, and the wing templates. You will also need to provide a pair of scissors, a sharpened pencil, pictures of airplanes from Activity 5, and a metric ruler. To prepare for the activity, make a copy of Activity Sheet 7 for each student. Make a copy of the wing templates for each team of 2 and an extra copy for yourself. For each team, cut 2 lengths of string 60 centimeters long each. Cut 2 extra pieces for yourself. Assemble the 2 wing models from the templates you copied. Each team of 2 will need 1 copy of the wing templates, a straw, a pair of scissors, 2 lengths of string, a sharpened pencil, and some transparent tape. To begin the activity, remind students of the work they did with Bernoulli's principle in Activity 6. Ask students, what caused the strip of paper to rise when you blew across it? According to Bernoulli's principle, faster moving air exerts less pressure than slower moving air or still air. Blowing air across the top of the strip caused the air pressure above the strip to drop. The higher pressure of the still air beneath the strip of paper then pushed the strip up from underneath, making it rise. Now have students imagine that the strip of paper is an airplane wing moving through the air at high speed. Then ask, how could you get the wing to lift like the piece of paper? Students should suggest somehow making the air move faster over the top of the wing than over the bottom. Next, pass around the pictures of the airplanes from Activity 5. Have students examine the shape of the wings on a variety of aircrafts. Then ask, what do you notice about the wings on every one of these airplanes? Students will see that all of the wings are curved on the top and relatively flat on the bottom. Some students may guess that this shape makes the air move faster above the wing than below it. Hand out a copy of Activity Sheet 7 and the wing templates to each student and the materials to each team. Make sure each team has a pencil with a sharp point on it. Students will need to share the rolls of tape. Instruct students to cut the straw in half. Then cut the template sheet down the middle along the solid line to give them 2 templates. Next, poke the holes, then fold and tape the paper. The box-shaped wing should be taped on 3 sides. Once the wings have been folded and taped, slide a straw through the holes and wrap a piece of tape around the straw directly beneath the wing. Then thread a piece of string through each straw. Have students compare the shape of their wings and ask, which model looks more like an airplane wing? Students should say the curved model. 1 student from each team should pick up the rectangular-shaped wing. Have them hold the string vertically and tilt the top of the string slightly away from their face. Then, guide students to blow straight at the folded edge of the wing. They will find that the rectangular-shaped wing does not respond to students blowing air at it. Next, have students pick up the curved wing and turn it so that the flat side of the wing is on top and the rounded edge is facing them. Again, have students tilt the top of the string back slightly, then blow air at the wing. Students should find that the curved wing, with the flat side up, does not respond to the airflow either. The wing is actually being forced down, but the tape on the straw prevents it from moving. Finally, have students turn the curved wing around so that the curved side is on top and the rounded edge is facing them. Have the students repeat the exercise. This time, students should find that the wing lifts when air is blown at it. Ask students, what must be true about the air pressure above and below that wing? Students should conclude that the curved shape of the wing makes the air flow faster above the wing. The faster moving air makes the air pressure above the wing lower than the air pressure below the wing. Bring students' attention to the cross-sectional diagram of an airplane wing at the bottom of their activity sheets. Explain that airfoil refers to the special shape of a wing, curved on top and flat on the bottom. Lead them to understand that an airplane's wings are shaped like airfoils to achieve lift. As the airplane travels through the air, the curved shape of the wing causes the air above the wing to move faster than the air below the wing. The air pressure below the wing is therefore higher than the air pressure above the wing, thus causing the wing, and the plane it is attached to lift. Have students label the airfoil diagram on their activity sheet. Faster moving air, slower moving air, high pressure, and low pressure. Then have them draw an arrow to indicate the direction of lift. Finally, let students know that in the next activity, propeller planes, they are going to discover how some airplanes use spinning airfoils to propel them through the air. To conclude the activity, let students keep their airfoils by having them remove the straws and store them in their folders. Return the rolls of string and tape to the kit. Save the pictures of airplanes for use in Activity 8. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.